Okay. Let's start a new project. Hello, hello, hello. Okay.
may come as a sur- It may come as a surprise, but roguelite shoot-'em-up games like Vampire Survivors or Brotato are some of the easiest, most satisfying games to whip up in a single sitting. In this tutorial, you will learn how to do just that. If you're new to the channel, welcome to GDQuest. I'm Nathan and I've been helping people learn to make games for the past 7 years using Godot. Why Godot? Because of all the game engines we've tried at GDQuest, we found it to be the most intuitive and easiest to pick up. It's lightweight and powerful, but most importantly, it's completely free and open source, so it helps preserve your right to access, understand and modify the software you will depend on to create your games. In this tutorial, you will learn to code player movement, a weapon, enemies that spawn randomly and move towards the player, player and enemy health, and more. Follow along till the end and you'll have created your first 2D game and become familiar with some of the most essential features of Godot 4, but that's not all. This video is sponsored by all the new and experienced developers who have bought GDQuest courses to learn how to make games with Godot. There are several Easter eggs hidden throughout this video. They are special coupons you can add up to each other for a cumulative discount on our great. So a zip file is a compressed archive files from the website. We'll need to import the project files into the Godot editor. To do that, we first have to extract the project files from the zip you downloaded. So a zip file is a compressed archive that brings multiple files and folders together in a format that's easy to share and fast to download. To extract the contents, you can right-click the zip file on most systems, new folder next to it, the executable file you downloaded from the website. If you don't have any projects yet, it will offer you to open the asset library to download. Click the executable file you downloaded from the website. If you don't have any projects yet, it will offer you to open the asset library to download some examples. You can click cancel because we don't want to do that. What we want to do is import our project. Click the import button at the top left. And then you need to navigate to the files you extracted. So in my case, it's in Downloads, 2D Project Start, and we want to double-click project.godot. If Godot recognizes the project, it will give you a green check mark, in which case you can click Import and Edit. This will open the Godot editor where we can get started. Upon importing the project, you will be presented with this empty 3D view. This is what Godot does when your game is still early in development and you don't have a level or something for it to open. This will change in a moment, but first let's go around the interface. So in the top left, you have the scene dock, and this is where we will create our character, our slimes, and the other entities in the game. In the bottom left, you can see the files that we included in the project in the file system dock. You can double click any folder you see there to expand it, and you'll see there are a bunch of files for characters, for the pistol of the player, and so on. On the right, you can see a dock named Inspector, and this is where you will be able to inspect the different game entities that you'll create in the scene dock. Let's do that and with the player character to see how the inspector works. So to get our scene, our player entity started, Godot gives us three handy options: 2D, 3D, and user interface, but we don't want these default options. Instead, we will click Other Node. This brings up a window where you can see all of the nodes, all of the basic building blocks of Godot games that Godot has. And there are loads of them, so you don't really want to search through them manually. Instead, we will use the search bar at the top. So you can click the search bar to highlight it if it isn't already selected and start typing character. One way to create characters in Godot is to start with a character body 2D node. So you can press enter or click create with the character body 2D node selected to create your scene. And you can see that Godot switches to the 2D view. I'm going to middle mouse, click and drag to center the view on the little dot that we have here that represents our character body. And we'll give it some visuals instantly by going to the file system dock in the bottom left. Expand the characters folder, Happy Boo, this is the player character, and you have a file named happyboo.tscn. This is a pre-made construct that we've made for you to have the character already animated. So click and drag this tscn file. You can drag it in the view and see your character. I'll use my mouse wheel to scroll in, or you can drag the file directly onto your character body 2D node. And this will create a copy of this template, this scene, as Godot calls it, that we named Happy Boo. This only gives us visuals. Now, if we want a character that moves and that can interact with the world, we will use the character body 2D node. And this one needs to have a collision shape as a child of it that defines the shape the physics engine will use to prevent you from going through walls and so on. To add a collision shape, we select the character body 2D node by clicking on it, and then we can click the plus icon in the top left of the scene dock or press Ctrl A or Command A on Mac on our keyboard. This brings up the Add Node dialog you saw before, and this time we're going to search for collision to find the collision shape 2D node. And you can press enter to add it. So on the left, you see in the scene dock, the collision shape node appeared, and the warning that was next to the character body 2D node disappeared because it expects at least one of these collision shape nodes. Now, if you select the collision shape 2D node by clicking it, in the inspector on the right of the editor, you will see some information about it. And the shape slot is currently empty. The shape slot is what will define the collision shape that this collision shape node has. So you can click on empty to see the options that Godot gives you by default. And we can use a circle, a rectangle, a capsule. There are different geometric shapes that the physics engine of Godot can use to detect collisions with walls and other enemies. We'll use a circle shape 2D to start with. So click that. And in the view, you will see a tiny little circle. So I'm going to use my mouse wheel to scroll up to get closer to this. And you will see that this circle has a little dot on the right. You can click and drag on that dot to interactively change the size of the circle. Note that for this to work, you need to have the select tool selected in the toolbar at the top of the viewport. There's another way to change the size of the circle by clicking the circle shape 2D. Resource in the inspector. And when you do that, it expands and gives you a radius property. And on that radius property, you can click and drag and see the size of your circle change. So when you click and drag the dot in the view, it changes the radius of the shape in the inspector as well. And that is all we need to get coding. But before we can write code on our character, we want to save our progress. To save the character we created as a template that Godot calls a scene, we can press Ctrl S on our keyboard or Command S on Mac. This brings up the file browser that allows us to save files in our project. I'm going to name this one player.tscn. TSCN is the file format Godot uses for scenes, and click the Save button. The character we have created right now will not do anything. The nodes we have allow us to add code to control the character, but without that code, they do not move by themselves. So we need to attach code to our character. To do this, we're going to select the character body 2D node and click this icon in the top right of the scene dock. The attach script icon. We can also right-click on the node and select attach script. This brings up a window where we can choose where to save the script, if we want to use some template code that Godot provides, and some more information, like technical information. So first, please make sure to turn off the checkbox next to template, otherwise it will give us some code that we don't want. And then for the path, you can save to res:// so this is the root of your project files, and then player.gd, and click create. This will create an empty script with the line extends character body 2D. This line means that this code that we are going to write adds code on top of all the code that Godot has in character body 2D inside of the engine. And actually, you can control click on this label, character body 2D, to open its technical documentation page, its class reference. So Godot has this built-in technical help that developers can use to see all of the functions and properties that are available on every node. And this can be accessed by control clicking text in the editor or going to help, search help, which lets you browse all the code features in Godot. I'm going to close the documentation page and we can get coding. The first thing we want to do is to define the physics process function. To write a function, we start with the func keyword. And in this case, we want to start with an underscore and start typing physics. And you'll see that Godot suggests physics process in parentheses delta. Press enter to confirm and complete this line. And this function is known as physics update or something like that in other engines. It's one you find in pretty much every game engine. And this is the function that the engine will hook onto and call each time it needs to calculate a physics update. Because games update physics and update the general game state many times per second to produce individual images. And so we use these update functions to run our code many times per second, which allows us to move characters, for example. We'll start by calculating the desired movement direction of the player. And for that, we'll use a feature from Godot. So first, let's create a variable that we'll name direction, and we'll use that to store the movement direction. We write the equal sign to assign to it, and then input with a capital I dot get vector. Okay, so input is an object, an entity that Godot provides that you have access in all your script to call some built-in functions that help you check for player input. And getVector is very handy because it calculates a direction vector as a 2D vector value. So it takes 4 arguments that are input names, input map actions, as Godot calls them. These are labels that we give to our input. And we made a few in this project, so we're going to use them right now and then see how you can create and edit your own. So start by writing quotes, and then Godot will give you a list of the input labels registered in your project. So we created the top 4, moved down, left, right, and up, which we'll use, and some for the user interface come by default and are used by the Godot editor. Anyway, this function asks us first which input action corresponds to the left direction. So this is move left. Then we write a comma, and we're going to then give the right action. And you can see that I'm not inventing them. These are told to me by Godot as I write the function argument. So I'm going to put another comma. And then for the third input action, I want the up direction, which Godot calls -y. And finally, the down action, which Godot calls +y. So this will give us a vector that we can use to move our character. And we can check that pretty quickly. So the character body 2D that we are working with has a property, a variable called velocity that is built in. And this allows us to give the character both a speed and a direction in the form of one 2D vector. So we write velocity. You can see that this turns slightly blue because this is one of the properties of our character 2D. And we write equals, and then we can say direction times whatever value you want. So you could say 600, something like that. So this would mean move in the input direction at 600 pixels per second in this case. So we give the character velocity, and then we need to call a function for Godot to move it. And this one is also built into the character body 2D and is called move and slide. So you can just call it. And if we run the scene by clicking this icon in the top right or pressing F6 on our keyboard, you're going to see, well, the character is in the top left, but if you press the WASD keys, you're going to be able to move the character already with just 3 lines of code. So
There's some problems in here. Wonder something. Open me a new Godot. I did something wrong. Start over. It's something I didn't understand to my engine. Probably they make a preset option. I don't want to use that yet. Let's see what happens if I don't follow. Use full shape. Let's group. Now we can move on. Yeah, no, see? It doesn't give me move left and right. They did something in the import stuff in there. They are going a little bit too much tutorial like for my taste. But I can't see the input. Yeah, I can see when I type that, but where is move? Now you see them. It didn't show in the first time. Okay, I will go do the same thing in both projects. So I can fail to do on my own. But I wanna try it without that too much help. This one is move left. I learned how to do this. We can do this. Right. Oh, hop. Up. Then velocity goes direction. Now I yeah. Okay.
So this is the
Let's move
basic
on.
way of moving a character body. And note that this will automatically take walls and other collisions we will add to our game into account. Let's see where these labels, the input actions, come from in the project. To do so, we go to Project, Project move named above on the
We can
right
skip.
of our panel, and then you click Add or you press Enter because you have a gun. You type the action name in this bar right above the panel, and then you click Gamepad, click it, mouse button, and do more than that. Actually, the beauty of this system is that we can associate multiple inputs with one label, which makes our code very easy to work with. So I'm going to click the plus button again. And now I'm going to say we can shoot with the space bar. So I'm just going to press the space bar on my keyboard, and Godot recognizes it. And then I click OK, and this adds the space bar on the keyboard. And I'm going to press plus again. And let's say I have a gamepad and I want the RB button. So maybe I'm going to click the filter input in there and say RB, which is the right bumper on the Xbox controller. And you can see that Godot suggests it after searching for it. And so I'm going to click OK there. And now I have 3 different inputs that can trigger the shoot action: clicking the left mouse, pressing the space bar, and the right bumper on an Xbox controller, or right shoulder on PlayStation or Switch controller. All right. So this gives you an example of how you can add new input actions. You can also add new inputs to existing actions using their plus button right there. And well, I'm just going to delete this shoot action because we will not use it in our game, and close the input map.
Good.
Our character can move, but it would be much nicer if it played animations. So if we go to the scene dock, you'll see that there's a camera slate icon next to Happy Boo. And this tells you that this entity is an instance of a template that Godot calls a scene. So it's a scene instance. And you can click the camera slate to open the source scene in the editor. So let's click it, and it will open Happy Boo. And we can go to the 2D screen at the top of the interface and use the middle mouse click and mouse wheel to zoom on the character. And you'll see in the scene dock in the top left that the character is composed of many of those nodes that we have created before. And most of these are sprite nodes, the one with the happy face there. It means they are individual images that we can move and display on the screen. So this is how we make a character typically in games, with a bunch of sprite nodes. And this scene has something called an animation player. And if you click the animation player, a new interface pops up at the bottom of the screen. It's an interface that allows you to design animations. So we'll cover the animation editor in another video. In this project, we have prepared the animations for you. And so if you click the drop-down menu at the top of the animation editor, you'll get a list of the character animations. And one we prepared for you is called Walk. And in the bottom right of the editor, you can click the bar next to the zoom icon to control the zoom level of the animation timeline. And you can use the playback controls in the top left of the editor to play the animation. So if I click play on the walk animation, you'll see my character walks.
This is
In
way
games with
faster.
a bunch of sprite nodes. The screen it's an interface that allows you to design animations. So if you click the drop down and in the play button of the editor, you can click the bar next to the zoom icon to control the zoom level of the animation timeline. And you can use the playback controls in the top left of the editor to play the animation. So if I click play on the walk animation, you'll see my character walks. And so we can access this animation player with code to play animations. And we've done that for you in the script that we attached to the Happy Boo character. So we're going to click that script to see that we defined two functions for you there, play idle animation and play walk animation. We can call these from our player script. So I'm going to close the Happy Boo scene by clicking the X arrow next to it. I'm going to fold the animation editor at the bottom of the screen. And I'm also going to right click on the happyboo.gd script and close it for now. Okay, so we are back to the player.gd script. From there, we need to do a couple of things. First, we're going to try playing an animation on the Happy Boo character. The thing is, the script that we have is attached to our player node, to our character body 2D node. And we want to call functions on this other Happy Boo node that represents the character visuals. To do that in Godot, we first need to get a reference to access the Happy Boo node from our script. So I'm going to click the player.gd script again. And the function that we use to get another node is called get_node. And from there, we can get one called Happy Boo. We can get the nodes by name or by path that we write as a string. And then it gives us access to this node so we can call its function. So you could say dot play underscore walk underscore animation. And this is a function that we defined in the script of Happy Boo, which is why we can call it on the Happy Boo node. If we press F6 or click this button in the top right to run the current scene, now as we move, you'll see the character is playing the walk animation. And it constantly plays it, which is not necessarily what we want, right? We want to play walk only when the character is walking. To do that, we use a condition. So above the line, when I play the walk animation, I'm going to use the if keyword to define a condition. And then we need to write an expression that will be either true or false. And what we can do is only play the walk animation if the velocity vector is long enough. This will be an indication that the player is walking. So we can write velocity dot, and then we can call the length function on that vector value, on that velocity, and this will give us the length of the vector as a decimal number. So we can write if velocity.length is greater than 0, we need to add a colon at the end of the line, and then we need to indent the following line to be part of this block of code. So in GDScript, it works a bit as in Python. The spacing that you have at the start of lines is meaningful. And so to put lines inside of a condition or inside of a function, you need to give the lines after the if, for example, an extra tab character at the start. And this is how the language knows how to group code together. So the condition says if the velocity vector multiplies 0, we play the game, is where we play the talking, and we can select the word that says walk and change it. Before we move on to creating the game scene, I want to talk about getting nodes because it's something central to Godot. So when we use the getNode function, we pass not just the name of the node we want, but the path to the node. Let me show you what happens if I change the hierarchy of nodes in my game. If I press F6 to run the scene, now I get an error. And the error tells us basically that the get node didn't find the node that we were looking for. So now, because Happy Boo is a child of the collision shape 2D, we can't just write Happy Boo, we have to write collision shape 2D / Happy Boo. So we give the name of a node, / to look at its children, and then the name of the child node, and we can make this path as short or as long as we want, right? This means that each time you reparent the node, you have to change these paths in your code. And we're going to see a feature that works around that and makes our lives easier. But first, notice one more thing. It's that if I change the code in both instances and press F6, the character still works fine, just as expected. And this tells you that the hierarchy of nodes and how you organize them is going to be up to you and what makes sense to your game. So you'll need to experiment with that. Of course, in this example, it's probably more natural to have Happy Boo next to the collision shape because they don't need to have a parent-child relationship, but you can parent nodes however you'd like and however works best for your game. Okay, so now I need to revert the path here in getNode to just Happy Boo because now it's not a child of the collision shape 2D anymore. So here's another trick. If I select some text, I can press Ctrl-D to select other copies of the same text in my script. So now I have two selections, and I can just edit my text and see it edits both instances simultaneously. So I'm back to the code we had at first. So there are two more things I want to show you here. There's a shortcut to the getNode function that people in the Godot community use a lot. It's the $sign. So I'm going to select the whole function call getNodeHappyBoo and press Ctrl D, and I'm going to replace that with $happyBoo without quotes. And this is the shortcut. When you do that, it's like calling the getNode function, so our code works just the same. Okay, great. But because it's a shortcut to calling getNode, if I reparent my HappyBoo again, I play the game and I get the same error as before. So I mentioned that there was a feature we could use to work around that. It's called marking nodes as unique name in the scene. You can right-click any node and click access as unique name. And when you do that, Godot will automatically find the node and keep it stored in memory for fast access for you. You can see when you do that, a person sign appears next to the node. And so we can, in our code, use that person sign instead of the $sign. So I'm going to select the first $sign, press Ctrl D to select the other one, and type person sign on my keyboard. When I do that, you can see that I'm not passing the full path to the node, just a name, yet if I play the game, everything works fine. Better, even, if I change the hierarchy of nodes, I can press F6 and everything works fine. Get the node only once at the start of the game for you, and when you call the getNode function instead many times, Godot has to do the calculations to find the node each time. With this feature, it does not. Now, the limitation of this feature is that it only works within that scene, within, the scripts attached to character body and all, and when we start to create the mob and the game, we will not be able to access this HappyBoo node from other places in our code base. Next up, we will create the main game scene. To start with, I want to rename the character body 2D node because when we add the player to the main game, this is the name that will display. You can double click on the name of the node and select the text and write whatever you want in there to rename, and then press Enter to confirm. I'll save with Control S, Command S on Mac, and we can get creating our main scene. Go to Scene, New Scene, to create an empty tab in the editor, and then we'll click on 2D Scene to create a new Node 2D at the root of our game. There again, I'm going to click the name and change it to game. It will be a bit more explicit, and press Control S, Command S to save the scene. So we could call it a survivors game, for example, because this is the kind of game we're making. Press Enter. The next thing we want to do is head back to the 2D view. To do that, I'm going to click 2D at the top of the editor, and we can add our player in there. So I'm going to fold the characters directory in the file system doc and click and drag player.tscn to the center of the rectangular area in the editor. This area represents our game window, or the screen, the area that will be displayed in the game. The background is currently gray and very ugly. We want to change that, and to do so, we're going to add a new node. So with the game node selected, press Ctrl A or Command A to bring the Add Node dialog, and start typing color rect. This is a user interface node, command A to gray and very ugly. We want to change that in the area that will be displayed in the game. The background is currently gray and very ugly. We want to change that. And to do so, we're going to add a new node. So with the game node selected, press Ctrl A or Command A to bring the add node dialog and start typing color rect. This is a user interface node that Godot provides that displays a rectangular area with the desired color. Click Create to add it, and you'll see a small rectangle in the top left. Top left. If you have the select mode active, you'll see these dots and you can click them to resize the node. And if you pull on the bottom right dot, you will be able to resize to cover the entire game area. Now, the problem is it displays in front of the player, so we can click and drag to reorder the node in the scene dock and place it above the player so that it draws behind, because the drawing order by default is from top to bottom, right? So color rect is going to draw first, and then the player draws after it, so it draws on top of the color rectangle. Let's add trees to the scene, which will give us two things: nicer.
Oh my god, my mic is muted. It's good to practice old learnings as well,
Visuals, and
right?
also a way to test the collisions of the player. In the file system doc, in the bottom left, you'll find a trees directory with a pine tree image. You could absolutely click and drag that image onto the game area to place pine trees. The thing is, this creates sprite 2D nodes, and these only give us visuals. They don't give us any collision information for the physics engine. So instead, we will create a new scene that uses this image and has collisions. So we go to Scene, New Scene to create the scene. And we're going to start with another node. This time, we are looking for Static Body 2D. As the name suggests, it's a way to describe a static thing in the game that is going to have collisions and block player characters, for example. Like the character body node, this needs a collision shape to function. So we can press Ctrl A and look for collision shape 2D. And like before, we need to give a specific shape to this node. So in the inspector on the right, we click the empty slot and select a circle shape. On top of that, I'm going to reselect the static body 2D and click and drag my pine tree onto the scene. And we can zoom in a bit to see it more closely and try to center the base of the tree on the crossing axes in the editor. These axes represent the position that the tree will have when we drag and drop it into the game. So this will allow us to place the base of the trees basically inside our scene easily. You'll notice that the collision shape appears behind the tree, so we can change the order to see it in front of the tree. And
Good thing is, normally I watch tutorial videos, like I did 2 tutorials, maybe 3. Normally I'm mostly going back in the video. Now I'm going
then click and drag
forward
on
in
the
the video.
dot to make the
We
collision
are learning,
match the base of the
learning.
tree. This means that the player will only collide with this circular area because we want the player to pass behind the top of the tree, right? The collision should only be around the base, which is really what is going to be blocking you. On top of that, we're going to add a nice little shadow to the tree, which will allow us to see another trick. How to first change the color of a sprite. So in the file system doc, we have a shadow sprite, but instead of opening the folders individually, one thing you can do to find a file is to click the filter files field and look for a certain name. In this case, if we look for shadow, we will find the ground shadow sprite. You can click and drag it onto the game scene and it appears in front of the tree. So I'm going to click and drag ground shadow behind the pine tree. One thing we can do that's pretty cool with the handles that you can see here is we can scale down an image just like we did to upscale our color rectangle. So you can click and drag on one of the dots to scale down the shadow. Now, the thing is, if you do that, it's going to push the size towards the opposite corner. So instead, you can press the Alt key and the Shift key down together while clicking and dragging, and this will scale the shadow uniformly, and you can make it so it has an appropriate size for the tree. The shadow is white, so it doesn't really look like a shadow right now. And actually, making sprites white allow us to recolor them directly in Godot. So this is why we made the shadow white. If you select the ground shadow node by clicking it in the view or by clicking it in the scene doc, in the inspector on the right, you can see it has a bunch of properties, of settings that you can change, many of which are behind folded sections. We want to expand visibility, and there you will see a slot named Modulate. that has a color next to it. This is a feature that allows us to tint the color of the shadow. And if it's white by default, the modulate property will effectively replace the color of the shadow. So click on the white color to bring up a color picker. And then on the right, you can click and drag on the vertical band to change the brightness of the color, making it darker and darker. So we want to make it slightly darker, and then in the circle in the middle, you can move the slot, you can click and drag to select a different hue for your shadow. So it could be slightly blue, for example. Click in the viewport to deselect the color picker, and you can see that now the shadow is slightly blue, and this will contrast well with the white background in our main game scene. Okay, let's save our scene. After renaming the node, we're going to rename it to tree, or it could be pine tree because it's a pine tree precisely, and we can press Ctrl S to save the scene into pinetree.tscn. If we go back to the survivors game, now I'm going to clear the file filter in the file system doc and fold everything. And now I can click and drag my pine tree onto the game area. So I'm going to click and drag a couple. I can even group them in clumps. I'm going to have a bunch, draw them however you'd like. And now if I press F6 or click the camera slate icon in the top right, I can run my current scene and move the character. And if I move against the trees, you will see that the character can get blocked or kind of slide against the base of the tree. And this is what the move and slide function of the player script does for us. It handles collisions automatically for us. Now you'll notice one problem. It's that sometimes I can go behind the trees, and that's great. That's what we want, right? When I'm behind the base of the tree. But when I move down, the character is still drawing behind the pine tree. So we could move all the pine trees up the hierarchy in the scene doc so that they draw behind the character, but then they would always be behind the characters. And what would be ideal is that if I am in front of a tree, I draw in front, and if I go up, I draw behind the tree, the player, that is. And Godot can do that for us. We can select the game node here and expand the ordering category in the inspector, and you will see a checkbox next to Y sort enabled. Note that if you hover any of these properties, you will get a technical description of how they work, right? It's more of a description for experienced developers, but it explains how the feature works. So if we select the game node and turn Y sort enabled on it, now if I move the character around the view, even in the editor, you can see a preview of the effect. So if the player is below the tree, it draws in front. And if I go above a tree, the player will draw behind. And any character or mob that we will add to the scene will do that. If I zoom in, notice how this works. You can see the cross that represents the position of the player. And you remember how I told you we wanted the crossing axes to be at the base of the tree. Well, this is because this determines the position of the tree in the game level. And this is what the Y sorting feature will use as a reference for the drawing order. So notice, if I move the player up right above the base of the tree, instantly the character draws behind. And if I go below the base of the tree, the player draws in front. Now, the good thing is that we have collision shapes, right, for the player and the tree. So what will happen is that the player will not be able to go, just above the tree like this because they can't overlap due to the collision. So the player will slide around the tree and move around the tree's collision circle, right? We can press F6 to test that, and you can see that it looks a little more natural when playing the game thanks to the collision shapes. Okay, one last thing I want us to do at this stage is to set this as our project's main game scene. And we can do that by clicking the play icon in the top right of the editor or pressing the shortcut F5. I'll change the collision shape of my tree, test that, and now you can see main game scene. If you want to change the main scene of your game, if you set another one by mistake, like the player or something, anytime you can go to Project, there, stop will work 2D nodes, so make them collide with the trees as well. Add node window scene to create a will change the path for your project. Next up, we'll work on mobs that chase the player. So let's go to Scene, New Scene to create a new scene for them. And we're gonna create a character body 2D node. So click on Other Node, and in the Add Node window, search for character body 2D. This is perfect to move the mob around and to make them collide with the trees as well. Okay, so we can already rename the node to mob for having a clear name. And next we will add the slime we prepared for you as a child of that. So expand the characters directory, and there you want to expand slime, and you'll find slime.tscn. You can drag and drop it onto the mob node. And like before, this is a scene that has a bunch of sprites, as you can see if I zoom in, and an animation player that's going to have animations for when the slime is hurt, when the slime is walking, and so on. And we expose them as functions, play, walk, play, hurt, in the script attached to the slime node. So I'm going to close this and head back to the 2D view, called the animation editor. And there we need to add one more thing. What is that? Well, it's the collision shape as usual. The warning tells us that next to the mob node. So select the mob node, press Ctrl A, Command A on Mac, and search for collision shape 2D. And once more, we go to the inspector, click the empty slot, and create a circle shape for the slime. This will be what the slime uses to collide, but also to damage the player upon touching the player. So we want to place the circle so that it encompasses the slime as best as possible. This will also be used as the collision shape for touching the slime with the player's bullets. That's our scene done, so we can save it as mob.tscn, will be fine. And we're going to add a script to move the mob. So select the mob node and click the Attach New Script button. Once again, we don't want a template, so make sure that the checkbox is turned off, and we can save it to the default path, mob.gd. Click Create to create the script, and we can get coding. I'm going to close the other tabs in here. And so we're going to have code that's a bit different from the players. Because the mob is an artificial intelligence, it's not going to listen to player input. Instead, we're going to make calculations to move it towards the player. So first, to make those calculations, we need to store a reference to the player to find the position of the player and follow them. For that, at the top of the script, we create a new member variable, a property of our script that we'll call player. For now, we can leave it empty and get coding. Assume that in this variable, we will get the player node, the character body 2D node of our player. So I'll head back to the script editor. You can click on script or press Ctrl F3 to do that, right? And we will define, once again, the physics process function, because there are collisions involved when the mob and the player move. So we need to use the physics process function to synchronize their motion with the physics engine. So type func underscore physics process, enter to complete. And then inside of the function, we will calculate the desired movement direction of the mob. And this is the direction from this mob to the player. So we can type a new variable that we'll name direction. And this one we'll use, so the position of the mob, and we will type global position. This is where this mob is in the game world. So this is a property that comes with many nodes, including sprites or character body 2D that we have access to in our scripts. Dot. First, this position is a 2D vector coordinate. So it comes with a bunch of vector specific functions. So we can write dot direction to. It's a function that will calculate the direction to a point, and that point will be the position of the player. So we can type player dot global position. And so this will give us the direction each physics frame to the player. Then the velocity of our mob will be equal to direction times some value. So something smaller than the speed of the player is good here. So 300 is half as fast. So mobs don't crawl onto the player too fast. And finally, once again, we can call move and slide. So you can see how to move an AI or the player, the code can be pretty similar. Now our code is not done because currently the player variable is empty. We need to get a reference to the player. There are a couple of ways
we are using signals, maybe.
Can do that. There's the more hard-coded way and the more flexible way. We'll start with the simple hard-coded way, and for that we need to save the file, move back to the survivors game scene, and I'm going to move to the 2D screen and add one of our mobs. So I'll fold the characters directory and click and drag mob.tscn onto the game board, right? And so let's see what happens first if we play with F5. Of course, we get an error because we have nothing stored in the player variable. So player.global position, like this is a global position of nothing. It's not valid code. Now, if I play the game again, I'm going to stop here with the error. And if you look in the top left, you will see our scene doc changed a bit. We have one tab called local and another one called remote. If you click remote, you will be able to see not the nodes of the scene you're editing in the editor, but instead the nodes of your running Godot game. So there you can expand the hierarchy and see exactly the node structure of your entire game, because when you put all these scenes together at runtime, Godot just creates all the corresponding nodes from the templates that you provided. And it adds a special one at the top called route. And so using this route, we can reliably find the path to the player node. It's route/game/player. So we can get that node in our player variable, right? So we can say get node, and we can type. So the way you write for the route, you start with a /, then you type route/game/player. Okay, let's try playing again after doing that. And we get an error, and this one is a bit longer. Basically, it tells you to use the @onReady annotation, blah, blah, blah. So this error tells you you're trying to get this node, but this is too early in the state of the running game. And this gets me to how getting nodes and how Godot creates these nodes in your game. So Godot, when you launch the game, is going to immediately run this code before even having added all the nodes to the game. The code that is outside of functions gets run very early when the game starts. So normally what we want to do is to wait for the engine to have created all the nodes in the game. And the way we do that is by using another special function from Godot called ready. Ready guarantees that a given node and all its children have been created. So inside of the ready function, we could write player is equal to, and then have our code to get the node. And there again, if we try to play, you can see that the slime can follow the player without errors. So that's cool. We can get our node like this. Now, there's a shorthand that's very commonly used by Godot users. Instead of writing the ready function for variables like these, we can use what's called an annotation. So I'm going to reset the code to what we had before. And in front of the var keyword, we're going to type @onReady. And this @onReady is equivalent to doing the ready function and the line we had before, right? OnReady makes the line of code execute around the top of the ready function. And it's a shorthand that you will find often in Godot because we at least used in Godot to use many of those kinds of lines of code.
Dude,
and having
weird.
OnReady prevented us from having to write 2 lines of code to set the variables at the start of the game. So we can do that. OnReady player is equal get node root game/player. And this works, but this works not only for one mob. If I go back to the 2D view and I duplicate the mob, to do that we can press Ctrl D and click and drag on the mob as many times as we want. Notice that if I play, all the mobs follow the player and they collide with. And this works not only for one mob. If I go back to the 2D view, that if I play, all the mobs follow the player and they collide with one another and they collide with the trees. Great. So the good thing about that is that the code that we wrote runs individually on each of the individual mobs. And this is the power of game scripts. All the code that you write implicitly runs on the node to which you attach the script. As I said, this way of writing the code is more of the hard-coded way. It works as long as the player node is a child of the game node. But if I reparent it to the color rect and press F5, of course, I get errors. And actually, so when I play the game and I get these errors, something called the debugger appears. It's a tool you can use. So this corresponds to our use of OnReady, the player. First, how would you avoid this hard-coded option? Well, typically would leave the player variable empty like this. And when creating the mobs from some other scripts, you would use code to create them, which we'll do later. You would set the player variable of the mob, and we will see how a little later in the project. But for now, nothing prevents us from leaving this line as a default. First, we will not move the player, but also, even if we did, we can use this code as a good default. And then from our game script or some other place, we will make sure that the player variable is properly set. And with that, you have mobs that move after the player. Next up, how about we make the view follow the character? We can do that using a new kind of node, a camera node. So I'm going to click the camera slate icon next to the player node to open its scene and select the player, press Ctrl A, and you can look for camera 2D. Once you've added this node, you're done. The view will follow the player. So if you play the game and you move around, the view stays centered on the player. Nice. Except that the white background stays in place, and so we end up seeing the dark gray that Godot originally had. Okay, so we can make it so this color rectangle does not move. For that, we head back to our Survivors game scene, and we're going to add a new kind of node that's called a canvas layer. So press Ctrl A to add the node. Look for canvas layer. It has this white icon with a brush, and create it. We want to move it anywhere in the scene, and add the color rect as a child of it. And instantly you'll see that regardless of the color rect's position in the hierarchy, the canvas layer and the rectangle will draw in front of everything. What the canvas layer does is that it renders, it bakes the children it has to some kind of image and displays that image behind or in front of everything else. That's why it's called the layer. If you've used a graphic design program before, they have this same notion where layers draw on top of one another. Now, the good thing is we can change the rendering order of canvas layers. So you can click the canvas layer node to select it, and in the inspector, expand the layer category, and then change the layer. Currently it's set to 1, and that's what causing it to draw in front of everything else. You can use any negative number in there, like you can click and type -30 or whatever, press enter, and now the color rectangle will draw in the back. And the good thing is that by default, canvas layers do not follow the viewport. As you can see, the follow viewport enabled property is turned off. This means that it will stay in place even when the view changes. So you can press F5 and move around, and there will always be a white background in your game. Next up, how about we work on the player's weapon, the gun? To do that, we're going to go to Scene, New Scene, and we'll use another kind of node that we haven't used yet. So let's click on the Other Node button for the root of our scene and search for Area 2D. It's a node that allows us to detect anything that's in an area, for example, the slimes in range of the gun. This node, like other physics nodes, like the character body, etc., needs a collision shape. So let's press Ctrl A and look for collision shape 2D. And once again, we'll create a circle shape 2D in the inspector and make the shape larger. You can make it really large because this circle represents the range of your gun. It's not going to collide and prevent the gun from moving into other things. We prepared a sprite of a pistol for you. So in the file system doc, you can search for pistol.png and click and drag the pistol onto the view. And you can see that it's really small compared to the range of the gun. And note that you don't have to make this circle very precise. You can come back anytime to change the size as we improve the game to make the gun shoot farther away or closer to the player. All right, now we want a way to rotate the gun around the player, right? So that when we rotate it, it doesn't rotate around its own center, but it rotates all around the character to shoot at enemies. There are a couple of ways we can go about it, but a simple way to do that is to give the pistol a parent node and to offset it from that node. Let me show you. I'm going to select the Area 2D node that I'll actually rename into Gun and add a new node as a child of it. There's a node called the Marker 2D, which will give us a visible cross in the view. And I'm going to add the pistol as a child of it. I'm going to call this marker 2D weapon pivot, perhaps. And I'm going to offset the pistol sprite from it. So I select the pistol node. And with the select mode active, I'm going to click and drag to the right and press the Shift key on my keyboard to constrain the movement to the horizontal axis. Select mode active, I'm going to click and drag to the right and press the Shift key on my keyboard to constrain the movement to the horizontal axis. Okay, so if I rotate the pistol node, it still rotates around its pivot point. But if I select the weapon pivot node and I rotate it, then it rotates the weapon with it. So this kind of setup where you have nodes with a parent-child relationship is a very easy way to offset the pivot of one or multiple sprites. It's not the only way, but it's a very common one. And we're going to add one more thing. We're going to define a point that's attached to the pistol from which we will spawn bullets. And so I'm going to select the pistol node and add another marker to the node as a child of it. And you'll see it appears on the weapons pivot. And I'm going to select the move tool. So move mode, you can press W key to select it, or click the 4-direction arrow in the toolbar, and then click and drag to move the node. And you can move it onto the mouth of the gun. And I'll call this one shooting point. And we'll use that encode to spawn bullets. Okay, I'm going to save the scene as gun.tscn, and we're going to add it as a child of the player node. So I'll open the player scene, and to do that, you can go find it in the file system.doc. But I wanted to show you this nice shortcut, Control-Shift-O or Command-Shift-O on macOS. And this shortcut allows you to find all the scene files in your Godot project and to type to filter the list. So you can look for the player scene this way and press Enter once it's selected. In the player scene, I'm going to click and drag my new gun node onto the player node. And you'll see we get the area of the gun, we get the gun around the player character, and you can see that it's too far to the right. And one cool thing we can do is that we can click and drag with the move mode active to move the gun up to be kind of aligned with the player character. Okay, so back to the gun scene, I'm going to select the pistol and move it to the left a bit to be closer to the player and save. And then when I go back to the player, it's a bit closer to the character, a bit nicer. Now, you might wonder, why do we have the gun as a separate scene? And the answer is, well, what if you want an enemy to have a gun? Or what if you want to have 2 guns on the player? Or 6 guns? Actually, on our website, you'll find a guide to have 6 guns, as in the popular survivor game Brotato. And this requires having the gun as a separate scene. So this gives you flexibility. This also helps to separate concerns, because when working on the gun, I just have to worry about a couple of nodes that are specific to the gun entity. All right, let's get coding. And the first thing we'll do is making the gun turn to aim at the closest enemy. So we're gonna add a new script to the gun node, to the area node, and we'll name it gun.gd. It's fine. And here we're going to define our physics process function once again to turn the gun to find enemies each frame. And now there's a very cool thing with areas. We don't need to get references in our code to enemies. The area node will detect overlapping enemies for us. It has a function called get overlapping bodies, and this function will find all of the character body 2D nodes that are overlapping with the area and return them as an array, as a list of values. So we can store that in a variable. So I'll call that variable enemies in range for clarity. And now we can check, are there enemies in range? And because this returns an array, a list of values, we can check for the size of the array. So we can say if enemies in range dot size is greater than 0, the size function of arrays will give us the number of items in the array. So if there are 0, we don't have enemies in range. But if there are 1 or more, there are some slimes in range, and we can aim at the first one. And so what I'll do there is find the enemy to target. So I'll create a variable again for clarity. Let's call it the target enemy. And it's going to be the first entry in the enemies in range array. So I'll say enemies in range. And there are a couple of ways you could get the first item in an array. So you can call the front member function of the array. It gives you the first element. Or you could use this syntax, square brackets, and a 0 inside of it, which is also common in other programming language. But I like the function for some reason. And once we have that, we can call a function that's available in most 2D nodes in Godot, if not all of them. It's called lookAt, and it allows us to look at a point. That point is going to be the global position of something. And so in that case, it's our target enemy's global position. So you write lookAt in parentheses target enemy dot global position. And one thing you may notice is when I write the dot after the target enemy, Godot doesn't know what the target enemy is, and so it doesn't give me completion suggestions for the global position. This is because it doesn't know the type of the value that we get from the array. And you'll notice that when I type the dot after the target enemy, I don't get auto-completion from the engine. And the reason is that Godot does not know what kind of value we get when we call enemies in range.front. It doesn't know that this is going to be one of our slimes of things, but this is not something we use in this series. Now, if you try to play the game, you'll notice that the gun turns to go down, and then it doesn't change direction. This is a bit weird, isn't it? Well, the reason for that is that the gun is probably detecting the player, which is a character body 2D, and so it's aiming at the player, kinda, right? Instead of only detecting the slimes. So we need to change our game setup to be able to target only the slimes with the gun. How do we do that? With the physics, layers, and masks in Godot. Select the gun node, and in the inspector, you want to expand the collision category. There you will see a list of layers and masks. The layer property controls what can detect this gun area, and the mask controls what our gun does detect. And currently it's on layer 1, so anything that masks layer 1 can detect it. We don't want that. We don't want anything to detect the gun, so we can uncheck that. And then it masks layer 1. So it detects anything on layer 1. It's physics layer 1, by the way. It's not the same as our canvas layer from earlier. The problem is that everything in our game is currently on layer 1, including the player. That's why it's always detecting the player. So we will uncheck layer 1 and mask layer 2. And now, if we play the game, the gun doesn't turn because it never detects anything. Indeed, we don't have anything on physics layer 2. Let's remedy that by heading back to the mob. We can use our nice shortcut to if you go and it masks 1. We're going to change that. We're going to set it to layer that. But we want to change its layer to 2 so that the gun, this will happen until we kill that slime or it gets out of range. Also, notice how the slimes stack up. This is due to our configuration with physics, layers, and masks. So we can remedy that by going to the mob scene, select the mob node, and you can test that by playing the game, and you'll see that slimes now stay apart from one another. We have a gun, but without projectiles, it's not very useful. So let's move on to creating the bullets next. Go to Scene, New Scene, and once again, we're going to use an Area 2D node. So click on Other Node and search for Area 2D. The Area 2D is very versatile because it can detect overlap with basically anything. So for a bullet, we can use it to detect when the bullet touches the mob and then damage the mob. I'll rename the node into bullet, and as a child of it, we need a collision shape once more. So let's add a collision shape 2D node. And in the shape slot, once again, we're going to create a circle shape 2D, right? We need some visuals for the bullet. So for that, we're going to expand the pistol folder in the file system doc and click and drag projectile.png onto the scene. I'm going to place a projectile behind the collision shape just to see the collision shape, align the bullet with the collision shape, and also make the collision circle bigger. Note that you can click to select the nodes, as we've seen before, but You can only do so if you are in the select mode. So if you are having trouble to select things, it's perhaps because you don't have the select mode active. Okay, so making the circle shape a bit larger will make it a bit easier to hit enemies and make the game feel a bit more fair for the players. We're going to add code to move the bullets, but before that, we need the bullets to hit enemies. And not only that, we might want them to stop when hitting a tree, for example, but we don't necessarily want other things to detect them. We're going to add the code to damage the enemies to the bullet because it's easier in the context of this kind of game. So let's expand the collision category after selecting the bullet node, and we're going to remove layers on it, and we're going to add masks 1 and 2. 2 is where the enemies are, so this will detect the slimes, and 1 would be for the trees. And if you want bullets to go through trees and through the background, you could turn off 1. It's up to you. Now let's add some code to move the bullet. So once again, we're going to select the bullet node and click the attach new script icon. And we want to name the script bullet.gd. Also, we're going to press Control S to save the scene, and we can get coding. So once more, we're dealing with a physics object. So to move it each frame, we're going to define the physics process function. And here we are not dealing with a character body node, so we don't have a move and slide function. You can see that when I try to type it, I don't get auto-completion for that. Instead, when dealing with areas, we need to move them using their position or global position property. So we're going to do that right now. We're going to use a trick with the bullet. We're going to use the current rotation of the bullet to move it, right? So when we create a bullet, we're going to have it rotated to match the head of the gun automatically. We don't have to do anything for this to happen. But then we want the bullet to move forward. And so if it's rotated like this, we want to move it diagonally like that. And to achieve that, we need to take the rotation of the bullet into account in our code. Here's how we can do this. We could create a direction variable once again. And this time, we're going to start by taking the horizontal axis. So we're going to create a 2D vector value. We haven't seen them explicitly so far, but we can construct any vector 2D vector coordinates using the vector2 type that we write here. Then we can have by the Godot engine for us horizontal right direction by typing .right. This is a constant value provided by the Godot engine for us. And if we control click on it, you will see that vector2.right is equal to vector2 and in parentheses 1, 0. It means a vector with a value of 1 on the x-axis and 0 on the y vertical axis. And on that vector, we're going to call the rotated function. So this vector2 function is going to return a new vector that is rotated by the desired angle. And we can get that angle from the rotation property of the bullet. Okay, so this will give us the current direction in which the bullet is pointing. And the good thing about that is that we can multiply that direction by some speed value, as we've done before, and it will move the bullet. So we can say position plus equals, we add to the current position of the bullet, direction times some speed. So you could say, I don't know, 1000 pixels per second, or you can type just 1000. And then we have to multiply that value by the delta provided by the physics process function. So we can say times delta. This makes the motion time dependent as opposed to frame dependent. So this is, again, something that you can learn in our free course, Learn to Code. The same, and we can test that in the editor by selecting the bullet and by rotating it. So to do that, you can select the rotate mode in the toolbar or press E on your keyboard and click and drag to rotate the bullet. And if you play the scene with F6, you will see the bullet shoot forward. So this is what this tricky code is all about. It might be a bit painful to think about at first, but this kind of code, once you learn to manipulate and work with it, will make your game code much shorter and easier than you might see in other game engines tutorials.
Yeah.
There's one more
This info is the today's best info.
thing that we want to do with the bullet. We want it to have a limited range. And one reason for that is just to limit the range of the gun. But another reason is that as the player shoots lots of bullets in the game, we need to at some point destroy them. Otherwise, they will accumulate and accumulate as the game is running, and they will start to affect performance. So back to our script, we can add a new variable that we'll put outside of the function so that the value stays around. We'll call it travel distance, and it will start with a value of 0. And then each frame, we will increase the travel distance value based on the current speed of the bullet. So we can write travel distance plus equals, and it would be 1000 times delta. Now, it's not the best practice to keep numbers duplicated in our code. Instead, we can create a constant that we will use to name the value. So we can write constant, C-O-N-S-T, and we can name it. The convention is to make it uppercase like this, so it will be our speed, and it's going to be equal to 1000. Now, we can select the 1000 we have in our code and press Ctrl D to select the next instance. And we can type speed to replace both instances simultaneously. Okay, we're going to similarly have a maximum range for the bullet. So we could add a new constant and name it range and give it a value of whatever, 1200 pixels here. This is so that we can check for the current travel distance, and if it's greater than the range, we destroy the bullet, like so. We're going to say if travel distance is greater than the range value, we add a colon at the end, and then we go to the next line indented. And to destroy the bullet, we can call the queue_free function. And we can test it, I think. So if I rotate the bullet to go diagonally, I press F6, and yeah, you can see that it gets destroyed after traveling 1200 pixels on the screen. To avoid doing too much back and forth between the scenes and scripts, let's add the code that will make the bullet damage the enemies. To do that, we're on the rotate next line, like so. We're going
Mhm.
And to destroy the bullet, we can call the queue_free function. And we can test it, I think. So if I rotate the bullet to go diagonally, I press F6, and yeah, you can see that it gets destroyed after traveling 1200 pixels on the screen. To avoid doing too much back and forth,
Why mine doesn't?
between the and yet the queue_free function. And we can
Okay, it works. It works. It works.
test it. I think so. If I rotate the bullet to go diagonally, I press F6, and yeah, you can see that it gets destroyed after traveling 1,200 pixels on the screen. To avoid doing too much back and forth between the scenes and script, let's add the code that will make the bullet damage the enemies. To do that, we're going to use a new feature of Godot called signals. So select the bullet node, the area 2D node, and next to the inspector on the right, you will find a node tab. Click it, and you should see the signals subtab highlighted. This lists a bunch of what Godot calls signals. They are messages that the node will emit when something specific happens. They're equivalent to events in JavaScript or to the observer pattern that you find in some programming languages. They are messages you can connect to, and when you do that, you can call code when the signal gets emitted. In this case, we want to connect the body entered signal. This one gets emitted whenever the area touches a physics body, like a character body 2D. And this is the kind of node that we use for our mob. So double click on the body entered signal, and a window pops up and asks you to select a node to connect and what they call a receiver method. This is a function that will be called by the engine when the signal emits. You can leave the defaults and select the bullet and click connect. This takes us to the script editor where Godot added the function we selected for us. It would either use an existing function or define the function for us if it doesn't exist. And in the margin on the left, you can see a new green icon. This one means that a signal is connected to this function in the editor. So you can click this icon to see, which node, which signal is connected to which other node. So the bullet's body entered signal is connected to this same bullet node, right? Now, inside of that function, we can write the code we want to call when the bullet hits an enemy or something.
Yeah,
The
I
first
love
thing we
these
want to
signals.
do is call queue_free again, as we did in physics process. This will destroy the bullet, but it will wait for one frame to do so. As to us as a function argument has method. This is a function that Godot provides on all of its nodes. In quote, we can write the name of the function we want to check. So we'll call it take damage, then a colon at the end of the line, and if so, we'll call body.take damage. This is something we call duck typing that we have access to in Godot. It's a way to check if a given code entity, a node, something like that, that we receive in our code has some property, some function. If so, we can safely call it. Next, we will work on the code to shoot the bullets. Let's head back to the gun scene, and this opens the gun.gd script for us. And in there, we're going to define a new function that we'll call to shoot one bullet. I'll call it shoot, so write func shoot, parentheses, colon. And inside of that, we want to create new copies of the bullet scene that we created. To do that, we're going to head to the bullet scene on a file system, and we can click and drag a file to get its path, in the code, and we're going to need that to load the file. So there are two functions you can use in Godot to load files in your code. One is load, and the other one is preload. Preload is kind of static, so you have to pass an absolute click and copies of the bullet scene that we created. To do that, we're going to head to the bullet scene on the file system, and we can click and drag a file to get its path in the code, and we're going to need that to load the file, kind of works bytes. So we're going to use preload, and so you can write preload, parentheses, and you can click and drag your bullet inside of the parentheses, and it will insert the path to the file for you. Now, we want to store that in a variable or a constant to be able to create instances of that loaded resource. So let's write const bullet before that. Remember that the convention for constants is to use uppercase letters. And this allows us to store a reference to our loaded resource. Then we're going to create a new bullet from that loaded template scene file. So we're going to write var new bullet, and we're going to call bullet.instantiate. Instantiate is the function you have on loaded scenes to create a new instance of that scene. And we store this instance in a new variable because we're going to need to make a couple of calls or modifications on that bullet. So we need to place that bullet at the location of the shooting point, right? We define that in our scene. And so we need to access the location of that shooting point in our code. What we're going to do, like before, is right-click on it and use access as unique name. We can click that, see the person sign appear, and back in our script, we're going to write new bullet dot global position is equal to shooting point. And when we complete that, it's going to add the full path in Godot 4.1, but we can just delete the part we don't want. So shooting point dot global position. This will move the bullet to the location of the shooting point. And we use global position in both cases because the regular position property is relative to the parent node, so to the pistol in this case, while global position is the absolute position in the entire game world. And finally, we will add our bullet. We can add it as a child of the shooting point. So we're going to copy this bit, shooting point, dot add child, and we're going to add the new bullet. This code that we have here is roughly what the editor does when we do this, when we drag and drop bullet.tscn onto shooting point. It creates a new instance of the bullet, it loads it if needed, it sets the location to match that of the shooting point, and it adds the bullet instance as a child of the shooting point. But we are doing that dynamically in code so that we can create as many bullets as we need. In this game, we want the attacks to be automatic. We want them to happen at regular time intervals. To do that, we will use another kind of node, a timer. Let's select the gun node and press Ctrl A or Command A on Mac to add a new timer node. Press Enter, and on the right side, we need to switch back from the Node tab to the Inspector tab. This will give us the properties of the now selected timer node. The timer tracks down time that is being spent, and it emits a signal each time it times out. By default, a timer in Godot is also running in a cycle, so it will emit this timeout signal at regular time intervals. The time interval is determined by the wait time property, and this will be the cooldown of our gun. We can lower the value by clicking on the field and writing something like 0.3, for example, to attack around 3 times per second. And we will also set the timer to start automatically by turning on the auto start property. Next, let's head to the Node tab because, as I told you, the timer emits a timeout signal, and we can use that to trigger our shoot function. So double-click the timeout signal and connect it to the gun node. This will create, by default, a function named onTimerTimeout. So let's click connect. And once we have this function, from it, we can directly call shoot. Now let's press F5 to run the game, and you will see that there are bullets that appear, but they are very strangely placed. Why is that? Well, this is due to how positioning of nodes work. When we create a new bullet, its position is relative to the shooting point. So when we set its global position to that of the shooting point, it gets offset. Also, when we rotate the gun, all the bullets we shot are rotating with it at an offset. Okay, this is not great. How can we remedy that? Well, luckily Godot has a feature to help us. We can head back to the bullet scene, select the bullet node, turn on the inspector tab, and we're gonna look for a property named top level. So you can click the filter properties field at the top and look for top. This will not unfold the sections for you, so you have to click on visibility to find the top level property. This will make the bullet move independently from its parent node. So now if you press F5, you will see it works a bit better, but all the bullets shoot to the right. And now the problem is that, well, we only set the global position of the bullets, but we do not change their rotation in the code upon creating them. So we have to head back again to the gun, open the script by clicking the script icon next to the gun node, and we need to add a new line after the one where we change the global position. So let's put our cursor on the line with nothing selected, press Ctrl-C and Ctrl-V to duplicate the line, and now we're going to select the global position text, press Ctrl-D to select the second instance of it, and change it to global rotation. And now our bullet will rotate to match the shooting point. So you can play the game, and you will see that now the gun shoots bullets towards the slimes. If I go back to the bullet for a second, we check if the hit body, the slime in general, has a function named take damage, and if so, we call it. But currently, the mob does not have the take damage function, so we will add it next. You can click on the mob scene at the top, and we'll open the scene and the corresponding script. And in here, we will define a new function named take damage. So func take_damage, and this function takes no arguments. And here we will do a couple of things. First, it would be nice if our mob had health, so we need to hit them a couple of times to kill them. So we can add around the top of the script a new variable named health, and you can set it to how many hits you want the mob to take before dying. 2 or 3 should be fine. Then, when the mob takes damage, we're going to subtract 1 to health. So you could write it health equals health minus 1, but there is a shortcut. You can just write health minus equals 1 to subtract that value to the health variable. So on the first hit, it will go down to 2, then 1, then 0. And when it's at 0, we want to kill the mob. So we can use a condition for that. If health is equal to 0, we use the double equal sign to check for equality. Then we're going to queue 3. And that's already a start. That's enough for us to test, if a mob gets hit 3 times, it dies. Okay, great. But it's a bit rigid and it doesn't look and feel too great. So we have a slime in the scene. So I'm going to head back to the 2D view for a second. And we created a script and animations on the slime, just like we did for the player. So if I open the slime itself, it has a hurt animation where it takes damage and a walk animation that we're not using at the moment. So we're going to remedy that. I'm going to close the slime scene, head back to the mob. And in the slime script, you can see we have 2 functions: play walk to play the walk animation of the slime, and play hurt to play the hurt animation. And then it resumes the walk as soon as the hurt animation ends. So I'm going to do 2 things. First, we're going to make the slime play the walk animation, and we're going to do that in the ready function. Remember, the ready function is called by Godot when the mob is created, when it's added to the game. So there we need to access the slime, and I'm going to, as we have done before, right-click, access as unique name, so that I can write %sign slime dot play walk, right? That will make the slimes play their walk animation. Each time a slime takes a bullet, they play the hurt animation. Okay, great. They disappear a bit fast, and so one thing we've done for you is provide a smoke explosion as well. It's a visual effect that you'll find in the smoke explosion directory in the file system doc, and we are going to instantiate it to add it via code when the mob dies. It will hide the mob disappearing, and it's a common kind of visual effect we use in games. So I'll expand the smoke explosion directory, and there you can see a smoke explosion.tscn scene. That's the template for the smoke. So like before, we are going to preload the smoke, and we are going to create an instance of it and place it and add it to the game. It's very similar to how we create bullets from code. So I'm going to control click and drag on smoke explosion.tscn onto my script, which will add this preload line. And so I'm going to store it in a constant smoke scene. And then we're going to create a concrete copy of that. So I'll create a new variable. I'll call it smoke, and I'll use smoke scene.instantiate, which creates a new copy, produces a new smoke explosion from the template scene. Then we need to add the smoke to the scene, to the hierarchy of nodes in our game. And so one way to do that would be to call add child and then add the smoke. The problem with that is that it would add the smoke as a child of the mob node. But then we have called queue3 that will delete the mob, and deleting a node also deletes all its children, including the smoke explosion that we have just created. So we can't do just that. So what we do instead in those cases is do something like this. There's a function called getParent that will find the parent node to the mob. So it will go one level up in the node hierarchy in our game, and then we can add the smoke as a child of that. Effectively, it will add the node as a sibling of the mob instead of having it as a child of the mob. And that way, even if we delete the mob, this will not delete the smoke. The last thing we need to do is to position the smoke onto the mob, because now we have added it as a sibling of the mob, so it will not share its position automatically. So we can write smoke.global position is equal to global position, and in this case, it's the global position of the mob when it dies. You can now play the game to test this. And well, the mobs snap a bit to the player, but you can see that it looks much nicer like this, with the mobs having the little explosion that hides them disappearing instantly. The player now can damage the enemies, but the other way around, it's not the case. So we're going to add health management to the player. So let's head back to the player scene and player.gd script, and we're going to add a variable to represent the player's health. But I want it to work as in Vampire Survivor. So as slimes stick to the player, they constantly damage them frame after frame. And for that, we're going to use a decimal number. You can write it as just 100, but adding .0, adding a decimal place, tells the computer that we want to work with a decimal number, not with a whole number. Then what we're going to do is each frame, we're going to check how many mobs are touching the player. And the way you do that in a game engine like Godot is by using another area. So we're going to add a new area node as a child of the player that will represent its damage box. So select the player node in the scene, press Ctrl A and look for area 2D again. And I will rename this into hurt box. This is a common name for these damage areas. This one will have its collision set to be on no particle layer and mask layer 2. That is, it will detect enemies touching it. Then, as a child of the hurt box, we need to add a collision shape. And you can make the hurt box any shape you'd like. Guess what I'll use? Yes, a circle once more. And I'll make it a little, add a no particle layer and mask layer 2. That is, it will detect enemies touching it. Then, as a child of the hurt box, we need to add a collision shape. And you can make the hurt box any shape you'd like. Guess what I'll use? Yes, a circle once more. And I'll make it a little larger than the collision circle. Note that you have a debug color field in the inspector. Then you can click to change the color of your hurt box. So when two collision shapes overlap like that, the drawing is not going to be perfect, but I'm going to change it to red or something to distinguish it from the other areas. Okay, so we have our hurt box. Now we can use it in our code to check when enemies are touching this box and inflict damage to the player. So I'm going to right-click on the hurt box node, access as unique name, which will let me access the hurt box using the person sign, and then click back on the player script so that each frame I can find the overlapping mob. Then you can click to change the color of your hurt box. So when two collision shapes overlap like that, the drawing is not going to be perfect, but I'm going to change it to red or something to distinguish. Make it box, we need to add a collision circle. Note that you have a debug color field in the inspector. Then you can click to change the color of your herd box. So when two collision shapes overlap like that, the drawing is not going to be perfect, but I'm going to change it to red or something to distinguish it from the other areas. Okay, so we have our herd box. Now we can use it in our code to check when enemies are touching this box and inflict damage to the player. So I'm going to right-click on the herd box node, access as unique name, which will let me access the herd box using the person sign, and then click back on the player script so that each frame I can find the overlapping mobs like this. I'm going to create a variable to store them, and overlapping mobs is going to be equal to herdbox dot get overlapping bodies. So we've seen this before. This function is going to give us a list, an array of the overlapping slimes, and we can use the number of slimes to damage the player. So the more slimes are sticking to the player, the more damage they take. We're going to have some kind of damage rate for the player. It's the amount of damage they'll take per enemy per second. So I'll create a new constant that I'll call damage rate. They could take 5 damage per enemy per second so that the health doesn't go down too fast. Then we can do a check like this. So if overlapping mobs dot size is greater than 0, actually we don't absolutely need the condition, we could do without, but we're going to subtract to health, right? If there are overlapping mobs, health is going to be minus equals damage rate times the number of mobs, so overlapping mobs dot size is going to tell us that number, times delta, because otherwise if we lose 5 health per frame without taking into account delta, the health is going to go down to 0 in an instant. So what we can do then is check if the health is lower or equal to 0. In that case, we're going to have game over. But we don't want to code the game over and display the game over screen right here. So what you would typically do in Godot is emit a signal for the user interface to catch and display the game over screen. So for now, we are just going to emit the signal, and we're going to define a custom signal. To define the signal, you have to go to the top of the script and write the keyword signal followed by the signal name. So in that case, we're going to call it health depleted. And so back to the bottom of our code, if the health is lower or equal to 0, we can use the health depleted signal and call its emit function. And this is how you can create a custom signal in Godot and emit it whenever you want, which has the same effect as all the built-in signals. We can then see the new signal in the editor, we can connect to it, and we can run code when the signal gets emitted. I'm going to bump up the damage rate to, let's say, 500, and I'm not going to add a print, I'm going to add a breakpoint to my code. You can see when I hover in the margin next to the code on the left, I get these red dots that appear. And if I click, I'm going to create a breakpoint. This means that the game execution will pause, just like when you get an error, when this line of code is about to run. And this allows us to check if some code runs, but also inspect the state of the game as it is running using the debugger. So I had a very high damage rate. So as soon as an enemy touches the player, they die. And so we reach this line of code and it does get emitted. So we could check that it is running, even if it has no particular effect. Shortcut for breakpoints, you can press F9 to toggle them on and off. And that way you can check if any line of code gets executed. And you can see you get the same interface as when you have an error, which is the debugger. So you can use that to help you and inspect everything that's happening in your game, see all of the variables in your script right there. It's really useful. And so if I press F7 to keep running the game, the enemies just keep touching the player and the health is in the negatives right now, but nothing happens because we're just emitting a signal. Okay, let's add a health bar now to the player so that we can at least visualize the health going down. And I'm going to lower back down the damage rate. So back to the player scene, I'm gonna click the 2D main screen to head back there. I'm going to add a new node. There are nodes built into Godot to represent health or progress bars. So I select the player node in the scene dock and press Ctrl A, Command A on Mac to add a new progress bar node. This progress bar is used for loading or those kinds of things. So with the select mode turned on, I'm going to scale it a bit so that you can see that it has, 0% marked on it. And I'm going to move it up with the Shift key pressed to center it above the character. And we're going to change the style a bit. So with the progress bar selected, go to the inspector. And the first thing we're going to uncheck is showing the person sign, because we don't really want that to show. And then in the inspector, you will see a range section with a bunch of properties. And so it has a minimum value, maximum value. So the minimum is 0. So this means that the bar can be select. And I'm going to, so with the select mode turned on, I'm going to scale it a bit so that you can see that it has, 0% marked on it. And I'm going to move it up with the Shift key pressed to center it above the character. And we're going to change the style a bit. So with the progress bar selected, go to the inspector. And the first thing we're going to uncheck is showing the person sign, because we don't really want that to show. And then in the inspector, you will see a range section with a bunch of properties. And so it has a minimum value, maximum value. So the minimum is 0. So this means that the bar cannot go below that 0 mark. The maximum value by default is 100. It's perfect. It's what we want for our health. And then the value, you can click and drag to pull it up. And you can see that as you change it, the bar fills and empties. Now, the problem we have is that the fill of the bar is currently gray. It's the default color, and it would be much nicer with green. We can change that by going down to the theme overrides category. And there we want to go to styles. So this system of theme and theme overrides is a very powerful feature of Godot for user interface creation. Actually, the Godot editor is made with this system. So all the styles, the icons, everything you see in there is controlled by this system. But as a result, it's a pretty complex and deep system that you'll have to learn bit by bit. Styles are provided for some nodes to create these rectangles that make our bar. So you can see there are 2 slots, background and fill, and the background is the dark gray area, and the fill is the light gray area of the bar. We want to change the fill, so we're going to click on the empty slot next to it. And we want to create a new style box flat. It's a tool that Godot provides to create these filled rectangles. And then you can click the style box to expand its properties and edit them. The first thing we want to change is the background color, the first property. So you can click that color and change it to a nice green. You can pick whatever color you want. And in this project, we included a Godot add-on that gives you a color palette for easy access to nice colors. Then you can go down to the corner radius. This allows us to round the corners of the health bar. So we have to set the 4 corners, and we're going to set them all to, I think 8 pixels is a good default, and can see that now the bar has some roundness. We can click the style box again to fold its properties, and then do something similar for the background, which is currently transparent. So we can click on the empty slot, add a new style box flat, click to expand its properties, and then for the background color, I'm going to choose the dark gray in my color palette. I'll navigate down and add some corner radius, so 8 pixels on all corners. And it might be a bit hard to see with the progress bar selected, but if you click in the empty space in your scene dock, you can deselect the progress bar and better see the round corners there. And then you can reselect the progress bar and press Alt on your keyboard and click and drag to resize it uniformly horizontally by clicking on the side handles. From the inspector and we reopen the player script, and in the player script, when we subtract health, so after the line that removes health, we're going to use %sign progress bar dot value is equal to health. And notice one interesting thing is that if we go to the inspector, we have a property named value, and in our script, we use the value property of the progress bar node. Well, the inspector actually displays all of the properties you can access from your code. And if you hover any of these properties, you will get a technical description, but also notice how it's for properties that have multiple words that are capitalized. You can see how the corresponding text in code is the same expression, but with underscore instead of the space, and everything in lowercase. So we could do something like progress bar dot max underscore value is equal to whatever, 500. And that would set the maximum value of the progress bar to 500. So you could use that to control the maximum health of the player, for example. Anyway, with this code addition, now when enemies touch the player, you can see that the bar progressively empties up. To turn our demo into more of a game, we're going to add random spawning of monsters around the player. So I invite you to select the Survivors game scene again, and I'm going to head back to the 2D view and also close the spawning of the player 500. In code is the same expression, but with underscore instead of the space and everything in lowercase. So we could do something like progress bar dot max underscore value is equal to whatever, 500. And that would set the maximum value of the progress bar to 500. So you could use that to control the maximum health of the player, for example. Anyway, with this code addition, now when enemies touch the player, you can see that the bar progressively empties up. To turn our demo into more of a game, we're going to add random spawning of monsters around the player. So I invite you to select the Survivors game scene again, and I'm going to head back to the 2D view and also close the other scene. So to do that, I can right-click on the tab and select Close Tabs to the right, and it's going to close the other scenes. We want to have mobs that come from outside of the view and flock to the player. Mobs automatically flock to the player already, so all we need to do is to define some kind of place where we want the monsters to spawn that is outside of the camera view. To do that, we'll use a feature built into Godot that allows us to draw a path in the editor. So select the game node and press Ctrl-A or Command-A and look for the Path 2D node. This allows us to draw a path, and for that we can use the contextual options that appear in the toolbar above the view. There's a green icon with a plus button, and this one allows us to add points. So select it, and then you can click anywhere far enough outside of the main game frame to add a point. And we're going to draw a rectangle that is larger than the game view. And monsters will spawn on this path. So I invite you to do 4 clicks, and don't worry if the edges are not too aligned, because we're going to fix that in a moment. And so once you have 4 points, you have an open curve, and you can click the rightmost icon in the toolbar that closes the curve, and it's going to add an extra point there. Then we can use the leftmost icon to select and move the point. So if you click and drag on one of the points, you can move it, and you want the shape to be roughly rectangular. It does not need to be perfect because it's outside the view. This is where the mobs will spawn. So it's completely fine if it's slightly off. Okay, so we have a path. Now we want a way to sample random positions on that path. And there again, Godot has you covered. As a child of the Path2D node, we're going to add a new node. So press Ctrl A and select the path follow to the node. This is a built-in tool in Godot that allows you to follow along the path. So notice with the path follow to the node selected, we have a little position icon there. And in the inspector, we have a progress and progress ratio property. We can use the slider on either of these and notice how this changes the position of our path follow to the node along the path. So the progress property lets us work with pixels, and the progress ratio with a value between 0 and 1, 0 representing the start of the path and 1 representing the end of the path. So by generating a random number between 0 and 1, we can assign that to the progress ratio and get random
It
spawn
doesn't change
positions
about
for the mobs.
This part is right because progress ratio we use in the other tutorial game use 0 to 1 because it never changed depend on the size of the rectangle. We use the get randef.
Okay, so let's
Rotation.
go to the code next
Right.
to add that. So the first thing we'll do is right-click on the path follow to the node and access it as a unique name, because we will need to change its progress ratio property and access its position. And then we want to scroll back up to the game node and attach a new script to that. And this default name works fine. So I'm going to create the script. And there we will write a function to spawn one mob. So let's write func spawn underscore mob is a good name. And we will first create a new mob instance. So how do we do that? We go find our mob scene, mob.tscn, and we control click and drag onto the script editor to preload it. And we're going to store that into a constant. Or perhaps we can directly create an instance this time just to switch things up again. So we can create a new mob variable is equal to preload mob.tscn dot instantiate, right? We can combine the loading and call to instantiate to generate our new mob. And remember that this call to preload, it's not going to be run each time. Once the computer has loaded the mob once, Godot will keep it in memory and smartly use the preloaded mob each time. So it's good performance-wise. Now we need to generate a random position for our mob. And the way we do that is by getting the path follow to the node. So if you type the person sign and path follow 2D, it's going to complete the full path to the node, but because we use the person sign, we can remove the first path component. And now we want to set the progress ratio of the path follow 2D to a random value between 0 and 1. And the function to generate such a value is called randf. It's a function built into the GDScript language that produces a number between 0 and 1, a decimal number. Okay, so this will update the position of the path follow 2D along its parent path. Then we can use that position to move the mob. So we can say new mob dot global position is equal to, and we're going to write path follow 2D dot global position. Finally, to have the mob be part of the game, we need to add it to the node tree. And for that, we can call the add child function. We call add child new mob, and this will add the mob as a child of the game node, just like the ones we have manually placed. Okay, so now we need to spawn a couple of mobs. One thing we could do is in the ready function, just for testing, we could call the spawn mob function a couple of times, right? So you can write spawn mob, Control C, and then press Control V several times to duplicate the function call. And I'm going to delete the mobs I had created before. So I select the 4 nodes with click, shift click in the scene dock, then press the delete key on my keyboard and press enter to confirm. And so if everything works fine, 5 slimes should come from outside the screen. So let me press F5 to try, and see, the slimes come. So the spawn mob function is working fine. Now, we need to keep spawning mobs as the game progresses. Ideally, we would do that every couple of seconds or, split seconds. How can we do that? With a timer node, the same node we use to shoot with the gun. So select the game node in the scene dock and press Ctrl A, Command A to add a new timer node. Remember that this timer, by default, will run in a cycle and emit the timeout signal. We can control how often it emits the signal by changing its wait time property. So I'm going to lower that to have one mob every 0.3 seconds or something, to have mobs come constantly and get a bit of the feel of those survivor games. Then I'm going to select auto start to automatically start the timer at the start of the game and connect its timeout signal. For that, we go up to the node tab, double click on the timeout signal, and we want to connect it to our game node. And it will call the on timer timeout function each time the signal emits. So click connect. And in the on timer timeout function, all we need to call is spawn mob. If we try the game now, I've deactivated the camera so you can see the mobs keep coming from outside the screen and they accumulate and accumulate, giving you more and more challenge. Now, after adding back the player camera, you'll notice that as I move around, the mobs keep spawning, and a problem is that the path is not fixed on the character, so it stays fixed around the original game area. But we really want the monsters to keep spawning around the player, and we don't want to see them popping. How could we do that? Well, nodes follow the position of their parent by default. So if we reparent the path2D to be a child of the player node, it's going to follow the player. To do that, you want to click and drag on the path2D node, and then you can use your mouse wheel to scroll up in the scene dock and drop it onto the player node. And if we do that, look at what happens. I can't see the mobs spawning again, at least not too much. If you do see them, it means that you need to make your path a little wider. But you can see how the mobs now still spawn from below, above, the right, etc. of the player. Of course, they tend to accumulate in an area because they are all chasing the player. The last piece is adding a game over screen. So when the health of the player depletes, we want to pause the game and just show a quick game over. For that, we're going to add a new canvas layer node, and we'll put some text on top of it. So select the game node and press Ctrl A to add a new canvas layer. And we'll call that the game over or game over screen. And as a child of the canvas layer, we will actually add two nodes. The first one is going to be a color rect, and we will use that to have some kind of shade to dim down the screen. And as a child of the color rect, we can press Ctrl A and add a label node. This is a node that displays text in the user interface. And this will allow us to explore the layout options of user interface nodes. So first, let's select the color rect node. I'll head back to the inspector on the right, and I'm going to give it a black color. So I click on the color, I click and drag on the right slider down to getting a black color. And then I want to make this a bit transparent. So you can see there are 4 channels that we can click and drag to change the color through individual color components. And the last one is called A for alpha, which means transparency. And so we can click and drag on this horizontal slider to make the color more transparent. It's a bit hard to see right now, so I'm gonna change the color rect settings so that it fills the entire screen. With the color rect selected, you can click the cross in a circle icon in the toolbar to get layout options. And we want to click the one in the bottom right, full rect, which will make it take the entire screen. Now you can see how our transparent color dims down the screen. As a child of that, we have a label node, and we want this one to display the text game over. So we select the label node, and in the inspector, we have a text field in which we can write the text game over. Now the problem is the text appears in the top left corner of the screen, but we want it centered. So with the label selected, again, we use the layout options that we have in the toolbar. And this time we want to click the centered dot icon that will center the text in its parent node, the color rect. So because the color rect is taking the entire screen, when we center the label, it centers it on the entire screen. Display share, we will actually add two nodes. The first one is going to be a color A, the black color. So I click on the color, I click and drag on the right slider down to getting a black color. And then I want to make this a bit transparent. So you can see there are 4 channels that we can click and drag to change the color through individual color print, and click the entire to display the text game over. So we select the label node, and in the inspector, we have a text field in which we can write the text game over. Now the problem is the text appears in the top left corner of the screen, but we want it centered. So with the label selected, again, we use the layout options that we have in the toolbar. And this time we want to click the centered dot icon that will center the text in its parent node, the color rect. So because the color rect is taking the entire screen, when we center the label, it centers it on the entire screen. Just to show you the power of these layout options, see how when I resize the color rect, the label stays centered, right? So these options are dynamic and they will automatically adapt to different screen sizes. So it doesn't matter if your player has a wide screen or a small screen, the text will stay centered automatically. Okay, another problem is that the text is really small. So let's change its size. Select the label again. And in the inspector, we want to go down to theme overrides, font sizes, and then we can change the font size property there. It's set to the default, which is pretty small, but if you click and drag, you're going to resize the text and you can play with different text sizes that work for you. And with that, you have a game over screen. Now we need to display it when the player's health is depleted. So we're going to do a couple of things. First, click the eye icon next to the game over screen so that it's invisible by default. Then we're going to access it from our code. So we right click on it, access as unique name, and this will allow us to easily access the game over screen. And the next thing we want to do is to connect to the health depleted signal we had created on the player. So let's go back to the player node, select it, and in the node tab on the right, we want to double click the health depleted signal and connect it to the game node. This will create a new function named onPlayerHealthDepleted. So I'll connect to that. And in this function, we want to do 2 things. First, we're gonna get the game over node with the person sign, game over, and set it to visible. So we can say game over.visible is equal to true. And then we want to pause the game. That way the mobs will stop moving and the player will not be able to move either. To pause the game in Godot, we need to access an entity called the scene tree. It's the root or the basis for all of your game nodes. And to access it, you can use a function called get_tree. You can access this function from many nodes. And this is on the scene tree that you will find a property called paused. So get tree dot paused, and you're going to set that to true as well, which will turn on the pause. Okay, so the player doesn't lose a health very, very fast. So what I'm gonna do is open the player script, and the damage rate, I'll set it to 500 again, so that when enemies spawn, I can go to them and I can die really quickly. You can see that we get the game over and the player is stuck. It cannot move and enemies stop spawning. And with that, we kind of have the complete game loop. You will need to press F8 and F5 again to replay the game, right? But you have a nice running game. I hope you enjoyed following this tutorial and to so that when enemies lose a health very, very fast, when I'm gonna really quickly, you can see that we get ripped, and the damage rate, I'll set it to 500 again, so that when enemies spawn, I can go to them and I can die really quickly. You can see that we get the game over and the player is stuck. It cannot move and enemies stop spawning. And with that, we kind of have the complete game loop. You will need to press F8 and F5 again to replay the game, right? But you have a nice running game. I hope you enjoyed following this tutorial and making a roguelite shoot 'em up. Don't hesitate to get adventurous and build on it to really make it your own. Remember, tutorials only
Why, Kevin, why?
work if you copy, customize, and then create. If you're just getting started with game dev, remember to check out the then we're going to access it from our code, so we can on the right deplete it. So I'll connect to that. Set it will stop moving. Tree. Very, very
Okay, we finished the game. I have a little problem with the game over screen, but not that big. So save this and finish the today's tutorial. I'm happy about the speed I can understand the tutorials now. It's my third game. First time I don't need to rewind the video too much. And it's promising for the next times. See you